Next, we'll take a look at some rules for exponents. And in particular, the rule we're going to pay attention to is called the product rule for exponents. And it says that a to the m times a to the n. So the setup is I'm multiplying like bases. My operation is that I can keep my like base and I can add my exponents, which is our formula. A to the power of m times a to the power of n is equal to a to the power of m plus n. So let's take a look at an example. X to the second power times x to the fourth power. I can use my product rule because I'm multiplying like bases. The product rule says that I can add my exponents. I'm going to keep my like base, which is x. I'm going to add my exponent, so this is x to the sixth power. Three to the second power times 3 to the third power. I'm going to keep my like base, which is 3. I'm going to add my exponents, 2 plus 3, which is 5. So this gives me 3 to the fifth power. So just to verify this, I'm actually going to take this out of exponent form just to see that we don't multiply our bases. We simply keep our base and add our exponents. So if I were to take this out of exponential notation, 3 squared is 9 times 3 cubed, which is 27. If we multiply 9 times 27, we get 243. If we were to raise 3 to the fifth power, that would be 3 times itself 5 times. We would also get 243. Next, we'll take a look at the power of a power. So this formula reads that a raised to the power of m raised to the power of n is a to the m times n. So we will multiply our exponents. So here's an example. X squared cubed. We're taking a power, we're raising it to a higher power, so we're going to multiply. So that's x to the power of 2 times 3, which is x to the sixth power. We'll take a look at another numerical example. 2 to the second power raised to the third power. We'll use the power of powers. We'll write this as 2 raised to the 2 times 3 power, which is 2 to the sixth power. Just to verify that we actually multiply our exponents, I'll take this out of exponential form and simplify this by using the order of operations, and we'll see that 2 raised to the second power raised to the third power is in fact the same as 2 raised to the sixth power. So the first thing I'll do is evaluate my innermost parentheses. So 2 to the second power is 4. Next, I evaluate 4 to the third power, which is 64. Next, I'll evaluate 2 to the sixth power, which is 2 times itself 6 times. That will also give you 64. And the product of power rule says that a times b raised to the power of n, because I have a product and I'm taking the power of my product, thus the name of this formula, product of powers, I will actually raise every factor inside of my parentheses to the nth power. So a times b quantity raised to the power of n is equal to a to the n times b to the power of n. So let's take a look at an example. 5x squared y to the third power, and that quantity is squared. So I want to take every factor inside of my set of parentheses, the 5, the x, and the y, and I want to raise each one to the second power. So this 5 has an understood exponent of 1. I want to multiply that by 2. X squared, x squared squared, so we have x squared times 2. And then we have y cubed raised to the second power, so that's y cubed times 2, which gives us 5 squared times x to the 4th times y to the 6th, which is 25x to the 4th y to the 6th power. Next, we'll take a look at a rule for exponent called the quotient rule for exponents. And it says that a raised to the power m divided by a raised to the power n, right, which is a quotient or a fraction, that's equal to a raised to the m minus n power. So whenever we're dividing like bases, we subtract exponents. So here is an example. 2 to the 4th power divided by 2 to the 2nd power. I'm dividing like bases, so I want to use my quotient rule. It says I keep my like base, which is 2, and then I take my top exponent minus my bottom exponent. 4 minus 2 is 2, and 2 squared is 4. X to the 5th divided by x squared. Here again, I'm dividing like bases, so I'll keep my like base and I will subtract my exponents, and we have x to the 3rd power. We'll look at one last example. Y squared over y to the negative 2nd power. So here again I have a like base, which is y. So the formula says that it's the top exponent minus the bottom. So I'm going to keep my like base, which is y, and I'm going to raise this to my top exponent, which is 2, minus, because there's a minus in my formula, my bottom exponent, which is a negative 2, so I'm going to put that in a set of parentheses. That double negative forces a positive, and 2 plus 2 is 4, so this simplifies to give us y to the 4th power. In this session, we'll take a look at multiplying polynomials. So the first type setup is a monomial by another monomial. And remember that a monomial is just a polynomial with one term. So here's an example. 5x times 3x squared y. So I want to simply multiply my coefficients. 5 times 3 is 15. I'm going to multiply x to the 1st times x to the 2nd. And that product rule tells me to add exponents, so I get x to the 3rd. And I'm simply going to carry along my y variable. So I get 15 x to the 3rd times y. Let's take a look at another example. 9c times 2a to the third power. So here again, I'm going to multiply my coefficients. 9 times 2 is 18. And I'm going to put my variables in alphabetical order. I can't actually multiply the c and the a because they're not like bases. So I'll simply attach them. 18 times a to the third times c to the first power. And here's an example of a monomial by a binomial. So keep in mind that a binomial is a polynomial with two terms. 2x times the quantity 7x squared minus x. So here again I have a distributive property set up. I have a quantity on the outside and I have a binomial on the inside. So I simply want to distribute 2x with every term on the innermost set of parentheses. So 2 times 7 is 14. X to the first times x to the second is x to the third. For my second term, a positive times a negative is a negative. 2 times the understood coefficient of 1 is 2. And x to the first times x to the first is x squared. I can't actually combine my two terms because they're not like terms. Next, we'll take a look at a monomial by a trinomial. Negative 6x squared times the quantity negative 7x squared plus x minus 3. So here again I'm going to distribute negative 6x squared. So if we distribute that with our first term, a negative times a negative is a positive. 6 times 7 is 42. X squared times x squared is x to the fourth. A positive times a negative is a negative. 6x cubed, because x squared times x to the first is x to the third. A negative times a negative is a positive. 18x squared. Next, we'll take a look at multiplying a binomial by a binomial. Now, there are actually a couple of ways to do this. We can use the distributive method, which we were using, and I'll do that. And we'll also use something called the FOIL method. And that FOIL method stands for first, outer, inner, last. It's just the manner or the order in which you multiply. One thing about the FOIL method is that it can only be used for this setup, a binomial by another binomial. It can't be used for any of the other setups we talked about so far, or any of the other setups we'll talk about after this. So let's take a look at an example. 5x plus 5 times 3x minus 1. So here I'm multiplying two binomials. The first method I'll use is the distributive property method. So in order to use that distributive property method, I'm going to take the 5x term and I'm going to distribute it or multiply it with every term in that second set of parentheses. And then I'm going to take the second term in my binomial, which is 5, and I'm also going to multiply it by every term in the second set of parentheses, and then I'm going to add everything together. Okay. So distributing my first term, and I'll simply do this underneath, 5x times 5x is 15x squared. Next, I'll distribute 5x and negative 1. So a positive times a negative is a negative. 5x times 1 is 5x. So next, I'll distribute 5. So 5 times 3x is 15x. 5 times negative 1 is negative 5. And then I'll combine my like terms. So I'll bring down 15x squared. I can combine negative 5x plus 15x. That gives me a positive 10x. And I'm going to bring down my minus 5. So I have 15x squared plus 10x minus 5. I'll also show you the FOIL method for this exact same problem. And keep in mind that the FOIL method can only be used for this binomial by binomial setup. So again, we have 5x plus 5 times 3x minus 1. So the FOIL method, the first thing I'll do is multiply the first terms for both of my factors. So 5x times 3x is 15x squared. So that's the F. It stands for the first terms. The O stands for the outermost. So my outermost terms are 5x and negative 1. So 5x times a negative 1 is negative 5x. The I in FOIL method stands for the innermost. So our innermost terms are 5 and 3x. So 5 times 3x is 15x. And L is the last terms. So 5 times a negative 1 is negative 5. Again, I'll combine my like terms, and you'll notice we get the exact same result as we did in the previous method, the distributive method. Now we'll take a look at multiplying a trinomial times another trinomial. Here we have 5t squared minus t minus 5 times the trinomial 7t squared plus 5t minus 1. So again, I'll use the distributive property technique, and I also line my terms according to their like powers. And I also align my terms according to like terms. So first I'll distribute 5t squared with everything in our second set of parentheses. So we have 35t to the fourth plus 25t cubed minus 5t squared. Next I'll distribute negative t. So that's negative 7t cubed. So I'll kind of group my t cubed terms minus 5t squared plus t. Next I'll distribute negative 5. So we have negative 35t squared minus 25t plus 5. And now I'll add up everything together. So that's 5 minus 24t minus 45t squared plus 18t cubed, and we have 35t to the fourth. So we have 35t to the fourth plus 18t cubed minus 45t squared minus 24t plus 5.